All right, so last time, actually, we just did a review of last time, factoring last time. So the time before that, remember we introduced three special forms. We had difference of squares, we had difference of squares, so that was when we had two quantities that we could read like it was a perfect square, and then they were subtracted from each other. And that factored as what? How did that a squared minus b squared factor? Oh, that was the cubes. Yep, you're thinking of the next one. So yeah. So for difference of squares, we do the a plus b and the a minus b. And we also had difference in sum of cubes. So let's go ahead and say difference of cubes here. We had a cubed minus b cubed. That's where we had a minus b. And I think that was the one you were thinking of, was the a squared plus ab plus b squared. Notice that when you have the difference of cubes, the sign here in the middle is the same. The sign here in the middle is the opposite. So when we do the sum of cubes, it looks almost the same. My goodness. Instead of a minus b in front, we'll have a plus b. And then instead of having a plus ab in the middle, we'll have a minus ab. Pardon me. All right. These are what we refer to as the special forms. When we have a two-termed polynomial, if it's going to factor, it's going to be one of these three. May not factor, but if it's going to factor, it'll be one of those three. So let's go through some of these, and then we're going to go through a review of factoring again. Let's look at this first one where we have x squared minus 9. Which of these three forms do you think it might be? Especially since it says x squared minus 9. Yeah, the difference of squares, right? So I have x, let's just write it out longhand here. I've got x squared. What number squared gives you 9? 3, right? You don't have to write this step out if you don't want to. I'm just writing it out so I recognize the form, right? I have a difference of 2 squares. What's playing the role of A? X. What's playing the role of the B? The 3, right? So according to our formula then, how does that factor? Yeah, x plus 3 and x minus 3, right? Because this is a squared minus b squared. So it's a plus b, a minus b. My goodness. Is that okay? Let's look at part B here. Again, I see an x squared. So it's probably not going to be a difference or sum of cubes, right? Let's do the second part first there. 9 is what squared again? It's 3 squared, right? Now remember, the first part, I need a whole thing squared. What whole thing squared will give me a 4x squared? What do we need to use? 2x, right? Okay. Because 4 is 2 squared, and then of course we have the x squared part. So what's playing your role of A? 2x, and the b is 3. So how does this factor then? And 2x plus 3 and 2x minus 3. So again, this is your A and this is your B. So this is where we have A plus B, right? And this is A minus B. There. So when you're applying one of these special forms, you need to identify your A and your B. Doesn't matter which of the special forms we have. That okay? All right, let's look at C together. When we look at C together here, what thing do you think we want to use? We want to use a difference of squares, a difference of cubes, or a sum of cubes? Difference of cubes, right? Definitely going to be a difference because there's a minus, right? And what's probably your clue that you want to use a cube? Yeah, x cubed, right? X to the third. Okay. So for your constant term, your 8, what cubed gives you 8? 2. So we have x cubed minus 2 cubed. Let me scooch this back over so you can see the whole formula. What's playing the role of A? X, and the B is 2, right? So how do we write this using your difference of cubes formula, this one here? Say it again. Well, then minus is what's in the formula already, so we don't have to use the minus with the 2. So you can always just treat it like it's a positive 2 in this case. Okay. Yep, we can write it as 2x, yep. To the second power, which is 4. That's exactly right. So again, we're using the difference of cubes formula. We said x is A, and the 2 is the B. So it's A minus B. That's what the first part is. And then it's A squared plus AB. Well, x times 2 is the same thing as 2 times x. And then plus B squared. 2 squared is 4. Let's do the next one together here. And then I'll let you work on E for a second afterwards. Which of the 3 do you think you are going to apply to part D here? Sum of cubes, right? There's a sum and then there's a cube, right? So it's probably going to be a sum of cubes. Again, we need to recognize that second piece as a cube of something, right? Right now it says 27y cubed. I need to write it as a cube of something. What cubed gives you 27y cubed? 3y, right? So what's playing the role of A? The X. What's playing the role of the Y? Or the B, I mean? The 3y. So how do we write using this formula now here, how do we write it? Good. Yep. Maybe x times 3y and then plus What's the last part? It'd be 3y, the whole thing squared, right? If this is your A and this is your B, I'm putting this B in here, here, and here, right?
So we know the exponent.
Say that again.
So if B has a variable, you have to put B in it. The variables.
Mm-hmm. Yep. And if we simplify this, then we get the 3xy plus 9y squared. We'll square the 3 and square the y. Work on E for a minute, and then we'll chat about it. Pardon me. Goodness gracious. Yeah. You have to ask. If you're not feeling well, just leave. Okay. Ready to chat? All right. Which of the three do you think we're going to use? Difference of cubes, right? Certainly going to be a difference because there's a difference, right? As I have got an x cubed and a y cubed. Use the difference of cubes. How do we want to rewrite the 27x cubed to start with? 3x, good. The whole thing cubed, right? Now using your difference of cubes formula, what did you get? 3x minus y, because your 3x is the A, right? And your y is the B. And then you get 3x, the whole thing squared, right? Plus, good. 3xy, good. Plus y squared, good. That's exactly right. And then I can simplify that 3x squared as 3x quantity squared as 9x squared plus 3xy plus y squared. If you are able to go from here to here, that's perfectly fine. I'm just going in steps so that we can see how we're applying the formula. Okay? The reason why I'm going from here to here is so that I can easily identify what the A has to be, right? One thing has to go in for the A. So I'm trying to identify what the A is, and then I'm just putting the A into the formula. The formula says I have to take what the A is and and square it. So I have to square both pieces of it. Is that okay? Let's look at a couple of these next ones together, and then we'll flip over to the other side and do a couple of ones that are a little bit more challenging, and then we'll go through a review of all the factoring techniques that we've talked about. Let's look at F here together to start with. Is 50 a perfect square? Is that one of our squares? No. So we can't apply this difference of two squares formula first. But there is something you should always look for first in any factoring problem. What is it? GCF. Is there a GCF here? 2. Factor your 2 out first. When you factor out the 2, what are you left with? Yeah, the x squared minus 25. Now do you see a difference of squares? $25 is what value squared? 5. Good. So how does that factor now? Good. X plus 5 and x minus 5. And again, if you can go from this step here right to this step here without writing the middle one, that's okay. I'm just writing this one so that we can recognize the perfect square there. Okay. If you're able to do from here to here, that's perfectly fine. You don't have to write the middle one. It's okay? Let's do G together, and then I'll let you work on H. And then, like I said, we'll do a couple of the more challenging ones here in a second. Do you see a GCF in part G? Yeah, what can we factor out? A Y and a 2? What are we left with after you pull out a 2Y? What is it? In the first term, we're going to have what's left? 9x squared. Not everybody at once. It's a little overwhelming. And then minus 1. Good. I see people mouthing it, but not actually formulating any sound. Or at least not sound that I can hear. All right, so that's what we get when the factor on the GCF. Again, if you're able to go right from here to the factoring, that's fine. But again, I just want to write it so we can recognize the A and the B again. What do we square to get 9x squared? We square 3x, right? So I recognize that as 3x, the whole thing squared, minus 1 squared. Again, if you're okay to go right to the factoring from here, that's fine. You don't have to show it to me. Okay? I'm just doing it so that we can recognize what the A is and what the B is. Okay? How does that factor now? Yeah, good. 3x plus 1, 3x minus 1. You can write it in either order. What you said was perfectly fine. Yeah. The A plus B, the A minus B again. Work on H, and we'll chat about it. Again, looking at this one, what's the first thing you should always look for in any factoring problem? GCF. What can you factor out? 5A? Good. Yeah, 5 goes into 45 and again goes into 20, and there's certainly an A in both terms. When you factor out 5A, what are you left with? Good, exactly right. We're left with 9x squared in the first term and 4y squared in the second term. Do we recognize that as a difference of two squares? Certainly not going to be cubes, right? Because it says squares, right? It better be a difference of two squares or there's not a lot we can do with it. What do you square to get 9x squared? 3x. And what do you square to get 4y squared? 2y. So then how does that factor? 5a stays out there and we're left with, yep. Good. And we get the 3x plus 2y and 3x minus 2y. And it doesn't matter which order you write those in, you get the same thing. Because again, we have a plus b and a minus b. Questions on that one at all? Let's do a couple more practice here together with the cube ones, and then we'll go through a review of factoring, and I've got another worksheet here for you. All right. Let's look at part A, because I think part A is a little bit trickier than ones that we've seen. First off, do you see a common factor in part A? Any common factor in those at all? No. Okay. So no GCF to factor out. This has two terms in it, right? It's a two-term polynomial. So if it's going to factor, it's going to have to be one of the three special factoring, special forms of factoring we're talking about, right? Okay. Which one do you think, by looking at it, which one do you think it's going to be? A difference of cubes, right? Definitely a difference because there's a minus sign. And I see an x cubed, right? Okay. So let's look at that one and rewrite it to help us out here. Obviously, hopefully obvious, what do we need to cube to get x cubed? We have to cube the x, right? What do we cube to get 64? 4. So that first part is 4x, the whole thing cubed, right? The second part, well, certainly we cube y to get y cubed. What do you have to cube to get z to the 6th? Z. So let's think about it. I need z to the something times a z to the something times a z to the something to give me z to the 6th, right? What do we do with the exponents again in this situation? We add them, right? So what do you have to add to itself 3 times to give you 6? 2, right? That would be z squared. So it's z squared cubed is what we need. So what's playing the role of a here? 4x. And what's playing the role of the b? Yz squared. So how does that going to factor now? Four x minus yz squared, good. Times, and 4x quantity squared. Oops, I just said quantity squared, and I forgot to write my quantity. And then, is it plus or minus? This was a minus, so this is a plus, right? They're opposite signs in there in the middle. Plus what? The 4xyz squared, right? Because I still have the 4 in there too. And then the last term is going to be yz squared, the whole thing squared. When we square the 4x, we'll get 16x squared. When we square the yz squared, we'll get a y squared. Z squared times z squared will give us z to the 4th. We add those exponents again in that case, right? Z squared times z squared will give us z to the 4th. That was a little more challenging, wasn't it? Let's work on D for a minute. D is like A, quite a bit like A. See if you can work on D for a minute, and then we'll chat about it. Oh, did you have it? Okay. Well, that's right, because I didn't give it on Friday, I gave it on Wednesday. You're right, yep. That's why you had them. Sorry about that. Ready to chat about this one? All right, what did you notice first in part D? Yeah, there's a GCF, right? What did you factor out? A 5 and an A again, right? What are you left with when you factor out the 5 and the A? Good. So we take out that 5A, we're left with the x cubed y to the 6th for the first term. 5 out of the 40 leaves an 8, and then a z cubed. Are we okay with getting the GCF out of there? Okay. Got the GCF out of there. Which formula do you think we'll use in this case? Sum of cubes, right? You agree with that? All right. In particular, there's a plus sign. The only sum formula we have is cubes. Okay. All right. So we need to figure out what the two things we're cubing are, right? I need something cubed plus something else cubed, right? I got to figure out what those two things that are cubed. What do you cube to get x cubed? X, good. What do you cube to get y to the 6th? y squared, just like the previous example, right? That's why I said that this d was a lot like the previous one. Okay. What do we cube to get 8z cubed? 2z, right? Yep, good. Now using our sum of two cubes formula, how does this factor? Good. Xy squared plus 2z, right? It's a plus b times xy squared squared, good, minus,
Is it 2z xy squared?
yeah, good. Xy squared times the 2z, it's exactly right, yep. And then 2z, the whole thing, squared. You can tell why I put lines through my z's now. You get two, my 2's and my z's look a lot alike. If there's not a line through it. Then if we simplify it, make it a little bit prettier. Xy squared squared is x squared y to the fourth. This will be 2xy squared z, and then that'll be 4z squared. Just making it prettier at that point. Typically, we write the constants in front and write the variables in alphabetical order. That's just making it pretty. Are we okay with the process? Again, if it has two terms, it's going to be one of those three special forms where it's not going to factor. Okay? One of the ones that you'll typically come across that doesn't factor, that they're trying to trick you with, is something that looks like this. That's a sum of squares, isn't it? 4 is a perfect square, yeah, but it's not a difference, right? Yeah. So this, when they have a sum of squares, this is not factorable. It's not, a lot of people will try to write it as x plus 2 times x plus 2. That doesn't work because when you multiply it back out, you'll get a 4x in the middle. This one just can't factor. If you see a sum of squares, that doesn't factor. That was one they'll try to trick you with. Okay? All right. So let's go through the handout that I just gave you with the summary of factoring techniques here. I've mentioned this already, but just to go through it again, your very, very first step every single time should be, is there a GCF? Right? And I've mentioned this already today. That should be step one of every single factoring problem you try to do. You look at it, see if you can factor out a GCF. Step two is recognize what form of factoring you're trying to do. Anything that you're trying to factor will have either 2 terms, 3 terms, or 4 terms. And we're not going to get any more complicated than that. It'll be a 2-term polynomial, a 3-term polynomial, or a 4-term polynomial. If it's 2-termed, if it's a binomial, try one of these 3 special forms. It's the only ways we have to factor 2-term polynomials. The only way we have to factor for binomials. Is it a trinomial? Trinomial, we've used AC method, right? That was our basic plan of attack for that. If it has 4 terms, then try grouping. Right? So that's going to be our plans of attack for doing these. Wonder if it was something I said. All right. So let's just go through these steps. Let's look at the first one. First step, is there a GCF? Yes. What is the GCF? 2. Good. We pull out the 2. What are we left with? Yeah, x squared minus 4x minus 45. That should be step 1, right? Okay. How many terms are left in this polynomial? 3. Right? So it's going to be factoring like we've done in every other trinomial. We could do AC, or remember, this is a leading coefficient of 1. When we have a leading coefficient of 1, we need things that multiply to negative 45 and give us negative 4. So what are factors of 45? Well, 1 and 45 work. What else works? 3 and 15. What else? 5 and 9. Again, if you see it, you don't have to write out the factors, right? I'm doing this so that you get used to the process every time. So if it's a minus 45, what has to happen? One's positive and one's negative, right? What do we need to use then? To get negative 4, what do we need to use? Yep. A negative 9 and a positive 5. We could have done this with AC method and done our factoring by grouping at the next stage, but this one, remember, when we have a leading coefficient of 1, we can just write it out that way. That okay? Okay with that? The next one, what will we use? What method will we use in that next one? AC, definitely, right? You do your 3 times your negative 4 gives you negative 12. Do our factors of 12. What do we get? 1 and 12. 2 and 6, 3 and 4. And that's it. Since it's negative, there has to be opposite signs. So what did you say we wanted to use? I think you just said a minute ago what it was. I need to get negative 11. So how are we going to get negative 11? Positive 1 and negative 12. So I'll have 3x squared plus x minus 12x minus 4. What can we factor out of the first 2 terms? X, and we're left with 3x plus 1. So what do we factor out of the next 2 terms? Negative 4, good. And we're left with plus 1. Good. Yep, that's right. Which is exactly what we want, right? We want a 3x plus 1 on both of them. So we pull out the 3x plus 1, and we're left with x minus 4. Good. Those look like ones we just did on the quiz, right? We agree? Okay. Let's look at number 4 together real quick, and then we'll do number 3 as well. We look at number 4 here. There's 4 terms. So we probably want to use what? Grouping, right? But again, first thing you should always look for is there a GCF? And I don't think there is in this case, right? So let's do by grouping. Group the first 2, group the second. The only way we have to attack something with 4 terms is grouping, right? What can you factor out of the first 2 terms? 2x, and you're left with 4a for A and 7y. All right. What can you factor out of the next ones? Yeah, 3, and you're left with, better be what? Better be 4a plus 7y again, right? Remember, if it's going to factor by grouping, we need the two groups to match, right? We need those two pieces to match. So then finally, what do we do? Okay, 4a plus 7y, and then I'll be left with 2x plus 3. Good. Is that okay? All right. Let's look at number 3 together again. First thing you should always look for is GCF. Do these two things have a GCF here? I think they do. I think 3 divides both of them. 3 goes into 24 8 times. 3 goes into 375 125 times. So I think we can pull out a 3. If you need to, use your calculator, right? Just start dividing both of them by the same number. See if you get something that goes into both of them. 24 divided by 3 is 8. 375 divided by 3 is 125. We have a 2-termed polynomial, a binomial left. So it has to be one of those special forms if it's going to factor. Which special form do you think is going to be applicable here? Difference of cubes, right? Difference of cubes, right? I see the difference and I see the cubes. So I got to identify that A and that B again. So what do we need to cube to get 8x cubed? 2x, good. What do we need to cube to get 125y cubed? Yeah, good. So we have 2x, the whole thing cubed, 5y, the whole thing cubed. So now how does that factor? Good, 2x minus 5y in the first part, and then 2x squared well, what's the sign going to be? Is it a plus or a minus first? A plus, good. I would just write it out. It's 2x times 5y, right? Because it's a times b, and then 5y, the whole thing squared. And then let's pretty it up. Square 2x we get. Yep. And then 2 times 5 is 10xy, good. And then we square the 5y, we get 25y squared, good. And remember again, if we use a difference or a sum of cubes, this trinomial here that never factors. You might even have to bother. This will never factor. Questions on that at all? Good news is this is the special forms of the last factoring technique that we have. That we don't have any more factoring techniques that we're going to learn. Bad news is that you're going to be factoring all semester. Okay. Pretty much everything we do involves factoring, including what we're going to cover on Wednesday. But just not to do any more problems, but just real quick, let's think about how we would attack these ones. Not to actually do them, but just how we would attack them. What would you use for the first one? AC is fine, right? The trinomial. There is no GCF to factor out. For the second one, what would you use? What would you do first? GCF and then AC. Yep, good. Third one, we would factor out a 3 and then do. Yeah, there's a difference of squares, right? Because of that x squared. Okay. Over here, it's cubes, right? Sum of cubes. Because you see that 27 and that 175. E you would use. AC again. F you would use grouping, right? A big part of this is just recognize how you would start, right? Am I going to use AC method? Am I going to use grouping? Am I going to use one of the special forms that we learned, right? So I'll leave that for practice. There will be answers posted on Google for those. Okay. On Wednesday, we're going to apply factoring to solving equations. Okay, so it's going to be our first application of factoring. Right? We're going to be doing this more and more as we go along. But our first application will be solving equations. So we'll start that on Wednesday. We'll do that Wednesday and Friday. I'm going to give you a little heads up. Wednesday and Friday, we're going to be doing those polynomial equations. Monday, we'll have a review sheet to work on because Wednesday is your exam. Next Wednesday, a week from Wednesday. Okay? Yes. Yep. Have a good one. We'll see you on Wednesday.